So animation, we have seen a little bit of it, but I'm gonna formally introduce it. So here, the goal is not to really make a sophisticated animation or anything like that. It's just to do something very basic. And what you really are doing here is to update a plot. So you create a plot and then keep updating it. And then if you want, you can create a movie from that, okay? And I'm gonna show you right now. So let's say, let's just start with something simple. And then we convert it to movies. So let's say we do that projectile motion, right? Remember, we did the projectile motion, but we did not make an animation from it. So now it's time to do it. So here, I'm going to create that code. And let's say for 10 seconds, and the increment is whatever you want, 0.1 of a second. And then the initial launch position is 0 and let's say 50 meters. And then the launch velocity V naught is whatever you want, 200 meters. And the launch angle is 30 degrees or 60 degrees. So these are the projectile data. And then you are going to now provide the equations of motion and create your vectors, and life is going to be very good. So first create the time vector. Time is equal to, you go from 0 with increment of dt to the time final. So this is your time vector. X is, if you know from your physics, what was X? Is x naught plus v naught times cosine of theta times what? Times t, correct? And here I'm using cosine d because my angle is in degrees. So this is my x of the projectile. Y of the projectile is y naught plus v naught times sine d of theta. This is the initial velocity in the y direction times t minus 0.5 times g times t squared. Now make sure when you do t squared, you use dot power because you're raising elements of the entire vector to power 2. So these are equations of motion, or the variables. You have some data that you the user has to provide. Now, I want to do one more thing before I do the animation. What was it? Do you remember? If I run this and say plot x and y, what is wrong? What could go wrong here? Do you remember? Let me run this. So I call it projectile animation. Let me run it, just plot it, and you tell me if you see something wrong or not wrong. Do you see anything? Now, maybe the velocity was too much. Let me reduce it a little bit. That was too big. Now what? Do you see something? Yes, it gone into negative wise, right? It's like it's continuing under the ground. So what I want is to eliminate the portion of the data which is beyond y of what? 0, less than y of 0. So how do you eliminate that? So trimming data. Y values. How do you do that? You say y when y is negative is equal to what? Right? Or if this will only trim y, it doesn't trim x. If you want, the other way to do it is you say index is equal to what? Find where y is what? Negative. Then you say what? T at those values is equal to empty bracket. X at those values is equal to empty bracket. And also what? Y at those values is equal to empty bracket, correct? And you set something to empty bracket means you get rid of them, eliminate them, trim them. So you found at which indices of y or x or t, they all have the same indices. Y's are negative, then you get rid of that. So now if you plot it again, it should be only continue to where it hits the ground. Okay, so it completely makes sense now. So this is just creating the data. Now I want to show a red ball or any other kind of shape moving along this path and animating it. So how do I do that? Take a look here. So this is what you do. If you want, you can plot the background curve, and let me use dash. Now you don't have to. I'm just trying to make it look nicer. Now I say hold on, and on the top of that, I want to plot a red ball with so much of size to follow this curve. So I say plot at point x1 and y1 at the beginning. What? A red ball. How do I do a red ball? What should I provide as the option for the plot to make it a red ball? R and what? O, right? A circle. Now, is that going to make it a red ball filled with red or just hollow? Hollow. It's just the edge of it that is red. Inside it, it's still white. So what should I do to make inside of it red too? What was the option? Excellent. Marker, face, color, and it should also be red. Now, this guy should plot for me a red ball, all red, edge and inside, where? Right at the beginning. Let's do it, make sure. There we go. You can see that. Okay? Now my goal is to make this red ball go along that path and create an animation. What should I do? If I were you or you were me, what's your idea? Change this point, correct? So instead of putting this red dot at x1 and y1, put it now at x2 and y2, 3, 4, all the way to the end point, correct? And how would you do that? Since it's a job that repeats itself, a for loop. So that's what you need. You say for I equal to length of x or t or y, doesn't matter. If you want, you can say x. Again, x, t, and y, they all have the same length, so it doesn't matter. So I already made one. Now it's time to start from point 2 all the way to end. Now what? You have to update this plot, this second one. The first one, you don't need to mess with it, just the second one. How do I update the data of a plot? All I need is, again, to change the x value of it and the y value of it. How do I do it? This is the way to go about it. First, you give a name to that plot you want to update. You give it a handle, what we call it, a figure handle. Whatever you want to call it. So I say h equals that plot. So what does this line 26 do now? Not only it plots a red dot at 0.11, it also gives that plot a name called H. So whenever you want to call this plot and give it some new data, you say, hey, H, this is the new data. Now, how do you exactly say that? You say set H and. There are two important commands for dealing with figure handles in MATLAB. And later you'll see them when we go make graphical user interfaces. The commands are called get and set, okay? To get data from them and to set data to. Set H and X data. Make sure X and D are capitalized. Now what? Change the X data of that plot from X of 1 to X of what? To X of I, right? Because right now I am at value I in general. Correct? And then a similar thing for Y data. So it says set H and Y data to what? Y at I. Yes? Here I'm updating the X and Y of the plot. And then I change the data, but it doesn't mean the plot will be redrawn. In order for me to redraw the plot, I say what? Draw now. It's all one word. Do not separate. Draw now means redo the plot with this new point. And then you say what? End. And that's it. Okay? Now let's see what happens if you do it. So here we go. Right? Now, if it's too fast, you can slow it down. If it's slow, then you are fine. But if you want to slow down something, what would you do? Anywhere in MATLAB you want to slow down something, use the command pause. And then in milliseconds, or in seconds, sorry, you provide the amount of seconds that you want MATLAB to do nothing. Just wait there and kill time, so making it slower. So you say every 0.1 of a second that you run this loop, every time, do wait for 100 milliseconds or 0.1 of a second, do nothing, let the time pass, then update. This makes the code slower. And if it doesn't, well, then you what? Maybe it's good for you, it's way fast, or no, then you can what? Increase this number. Clearly that makes it slower. Okay, so you can have some animation. So far, okay. So it's up to you. Now, if I want to stop this halfway in between and do some modification, what should I do? I don't want this animation to go forever. Let's say in the middle, I decided that the pause was too much, right? Let's say I make this 2 seconds, and then I say, oh gosh, that's so slow. And I don't want to wait forever for this to happen, right? Because it takes a lot of time, 1-2 minutes. So what should I do to stop it right here? Yeah. Control C, excellent. I mentioned that. Whenever you want to stop the execution of the code, you do what? Control C, you can stop it right there. Okay, so that's an important thing. Okay, so this is some simple thing. Now, what can we do to improve this animation? What's your guess? Can we add some ground or something? Some flat surface to represent the ground? Yes. How do I do that? Let's say I want a line from 0 all the way to 60 in black or whatever color you want, and I want that to represent the ground. How do I do it? Go ahead. I just need to connect 2 points together, right? Point 0, 0 connected to what? Point x 60, y 0. Just connect these 2 points. Yes, I can do it with the plot command. So before I do this red point, I say what here? I say plot. For x, you provide the x vector. For y, you provide the y vector, and then the color options. This x is the x of all points, the entire x vector. X of first point is 0. X of last point is what? 60. Y of first point is 0. Y of last point again is what? 0. And then I want the color to be what? Black. So I make it K. And then what? I want it to be a little bit thick. So I use what option? Do you remember? Line width, right? And I use, let's say, 3 pixels. So now this guy is going to be what? The ground. So now look. Here. Do you see the black line? So it makes it a little bit more realistic. And I can make a lot more if I want, right? I can do a lot more. I can add probably some picture here that represents like a cannon or something, right? It's just up to you how to add some shapes. And there are so many commands in MATLAB for creating shapes. Really? Yes. I can show you some. There is even a code that I told you. You can pass it a text, and that text, it will convert your text into voice. So I remember when I did it, here when it hits, I added the sound boom. And it said that, okay? That's quite nice, right? So let me show you. Might be some fun. Instead of just... here. So whenever everything is done, I say boom. Now you don't have this code, so don't write it. I have to share with you this function. Okay. Let's see if I have audio here. First time is slow. There we go. Yeah, first time it opened because it works through Excel. Okay, so it opens Excel to do it. So first time it is quite slow, but next time it's a little bit better. Come on. Yeah, a little bit slow, but it gets the job done. Okay. So you can do so many things. I remember I even had an explosion picture here, and I added it on the top of this picture. It was like an explosion. So you can do so many nice things to it, okay? It's completely up to you how you want to handle that. But let's see. So this is just making a simple animation, and now the thing is, how do I convert it into a real movie that, let's say, I want to add to my PowerPoint, okay? Because you can run this only when you run the MATLAB code, but let's say you have a presentation and you want to show the animation of a mechanism, like what? Like this double pendulum. These are the equations for a double pendulum. And if you want, I can show you that. Not equations of motion, really, just arbitrary angles. So if you want, I can show you how to make a double pendulum. And the goal is, now that you have this double pendulum, how would you convert it into movie, an AVI movie that you can import into PowerPoint? The command to use here is called getFrame. What is getFrame? What getFrame does is takes a snapshot, like snipping point. Okay? It takes a snapshot of the current picture. So whenever it's here, it takes one snapshot. Here, another, another, another. And each one of those snapshots, you can save it as what? Frame M of a movie. Okay, so this movie here, MOV, that you can see, that's what? That's a movie variable. And it has so many frames. Okay, it has so many frames. So when you get all the frames of the movie by snapshots, then there is this command called video writer. And you can convert your variable that was a bunch of frames. Now you can convert it into what? An AVI movie. Okay, so let me show you that. So here I'm going to use this simple simulation I have here. There we go. CLC, clear all, close all. T is that. This is a nice one too. That's a nice animation. Then I have Z, figure 1, H, Z limit, first frame, take a snapshot, then start from 2 to what is going wrong here? Doesn't like something. There's a parenthesis or something missing. Yes. Yes. And here it has to be 1. Here. So you see here, I'm creating a surf plot instead of a single 2D plot. It's a 3D plot. I give that plot, again, a handle name. I take my first frame and save it as the first frame of that movie variable. Then I keep changing my time. Each time I redraw my plot by changing the Z data. If you have a 3D plot, not only you have X data and Y data, you also have what? Z data. So I'm changing my Z data, and then each time I redraw it, there is a new command here called flush data. What is this? This means whatever data that was created in the previous loop iteration and you don't use it anymore, throw it away. Don't make the memory so crowded with the variables that you don't use anymore. Clean up the memory. You don't have to use it, but it's good when your animation involves lots of data. And then you're doing some pause, taking frame, and let's run this, see what happens. This is a nice one. Oh, what happened? Give me error? Oh, it does not have flush data. That's interesting. Unless they removed it, as always. Here. Right? You see, it's changing the height of the peaks and updating your 3D plot. It took a bunch of frames, snapshots, and now it has saved it in the workspace in a variable called MOV. And if you look at it, it has what? 101 frames. What is the structure of it? What kind of variable is it? It is called a structure. What is a structure? We'll see later. Don't worry about it. Just know that this variable contains 101 snapshots. Now I want to convert those snapshots into an actual AVI file that I can import, let's say in PowerPoint. So what do? As I said, the command to use is called video writer. If you want to play it in MATLAB itself, you can. So can MATLAB play those frames for me? Yes. The command to play those is called movie. So if you really want to play it in MATLAB, you can use the command movie. Then MATLAB plays it for you like media player. Okay? So here I'm playing it with the command movie in MATLAB, which used to play a bunch of frames. I'm asking to play twice and with 10 frames per second. Okay? So you can see that. But again, this is a figure in MATLAB. If you really want to save it as an external file, as I told you, the command to use is called video writer. The first thing you do, you give your file a name. So here I call it my first movie.avi. You can call it whatever you want. And I give it a name. So this name is the name of that variable object. Then I say open it. So this is like opening and closing files. I say open that file, then what? Write to that file what? The variable MOV, which has all of those frames in it. And then what? Close it. Okay? So look what happens here. I say, hey, open the object created with this name, open it, let me put all of my frames in it as a movie, and then close it. And now if you look, in my current folder, I have what? An AVI movie called My First Movie. This guy, you can play with Media Player. And you can import in PowerPoint, Word, or anything else. Okay, so I wrote it. I compiled it and wrote it into an actual movie. .avi. Right? So this is how to create some simple animation. So far, okay. Do you want me to show you another demo or move to the next topic? Sure. Let's do the pendulum then. So here we have a double pendulum. And this double pendulum, the equations for the two angles are given versus time. I want to animate this. Okay? So what do I need here? I need 4 objects, 2 lines in red and 2 circles in blue. And I need to update them based on these 2 angles, theta 1 and theta 2, correct? And then what? L1 and L2, and t is between 0 to 10 seconds. So just before we do anything, let me show you the background theory of it very fast, then we get into coding of it. So what you have here is you have 4 critical points that you need to update, or 2 points, not 4. 4 x and y values in total. So you consider an origin here. Let's say I put it at this top pivot point, and I call this x and y. So if I ask you, what's the coordinate of the first pendulum? What is it? Can you tell me? Based on L1 and theta 1? Where is this point located? What is the x of it? What is the y of it? X is what? L1 sine of theta 1. If you look, what is the y? Negative L1 cosine of theta 1. That's the location of the first pendulum. And what about the second one? That's L1 sine theta 1 plus L2 sine theta 2. Correct? This much, you have to add it to the other one. And what is the y value? Negative L1 cosine theta 1, negative L2 cosine theta 2, correct? This amount will be added to that one. So these are the coordinates that you have to keep updating. Why? Because your theta 1 and 2 are updating based on time. Agreed? So let's do it. So let's go back to MATLAB. And we simulate this one. So first we need t. It says between 0 to 10 with some increment. Let's say that increment of 0.1 is good. Then we need to create those plots. If you want, you can also type in the values of L1 and L2. Let's hard code them, 0.6 and 0.5. L2 is 0.5. And also I can type in the values of theta 1 and theta 2. Now, if you don't mind, I call them, that's fine, let me call them theta 1. Theta 1 is what? Pi over 3 cosine 2 pi. So is pi over 3 cosine 2 pi times t, right? Pi over 3 cosine 2t plus sine t. Pi over 3 cosine t plus sine of t, cosine of 2t. And theta 2 is pi over 6 times cosine 2t minus 2 sine t. Okay, so these are the equations for t, theta 1, theta 2, L1, and L2 that are given by the user. So these are inputs. Now we have the animation. So what do I need for animation? First, I need to plot the mechanism in its first position. And then I keep updating it. As I said, I need 4 entities to update. The 2 red lines and the 2 blue balls. They need to update. So what do? I need 4 handles. So first I say figure, open and blank figure for me. Then I say H1. This H1 is the first red line. Or if you want, I can call it H of line 1. Okay, handle of line 1. What is it? I want to plot now a line from 0.00 to point what? L1 sine theta and negative L1 cosine theta for what t value? For the first t value. So this is what I do. I say plot for me 2 x's and 2 y's and a red line. And red line means this, correct? So what are the x's of the 2 points? X of the first point is 0, y of the first point is 0. That's the origin. What is x of the second point? If you remember, it was L1 times sine of what? Theta 1. But theta 1 where? At the first point, correct? And similarly, y of the second point is negative L1 but cosine of theta 1 at point 1. Okay, so this line, this command is going to draw a line between origin to the first pendulum location. Now I say hold on. Don't redraw on the previous one. Hold on. Now I want you to plot for me. This is the handle for the first ball. This time you don't have 2 points to connect. You only have 1 single point. Where is that point? This is the x of the point. And this is what? The y of the point. Just the same x and y used for the end of the red line. Now instead, this guy is going to be what? It's going to be a blue ball. And if you want to fill it, what should you do? You have to say marker, face, color, and blue. So now it is going to be filled with blue. This guy also, if you want to make it thicker, you can use line width. You don't have to. I would like the pendulum to be a little bit bigger, 2 pixels. So this is the first line, then the first ball. Now I need to do the second line and then what? The second ball. So what's the second line? Line number 2. Another red line, but this goes from which point to which point? The end of the first point to end of the second point. This is end of first point. What's the end of second point? Anybody knows? It's this guy here. L1 sine 1 plus L2 sine 2. So we have to type that guy in. So L1 sine 1, this is going to be L1 sine 1 plus what? L2 sine 2, correct? It connects this x to that x. And then, let's go to the next line. And then this y, which is the y of the first point, to the y of the second point, which is this guy. Again, with the red line. Okay? If you don't like the second pendulum to be red, you can change the color. I can make it green. Who cares? And finally, I create a handle for ball number 2, where I put the location x, which is this guy, and y, which is this one, with another object. And again, if I don't like the color, instead of blue, I make it whatever you want. Let's say black. Okay? So now I'm good. I got all 4 handles done. If you fall behind, don't worry. This is going to be recorded in a video. You can practice it later. Now I go in a for loop and say for I equal to what? Length of t, keep updating each one of those data with what? With the new x and y data. So for example, HL1, the plot for the first line. What was the x data of it? This is the x data of it. So I bring it down, but instead of theta 1 at 1, I say theta 1 at what? At the current index II. Then I update the y of it. Y of that is this guy. Again, this is going to be II. So here is updating the first handle. Then we go to second handle. Second handle is called h of ball number 1, where x is simply this. Oh, wrong place. X is simply this one, and y is simply this one. Done. Then I go to the next 2. So this time is going to be line number 2 and then ball number 2, where x of line number 2 is this big guy here. Again, anytime you see 1, replace it with II. And then y of that is this one. Okay, so now that one is updated, and finally, X and Y of the last one. Something is wrong here. It does not like it. Let's see. Oh. You have to be careful when there are too many parentheses and brackets and everything. It doesn't pick on you. Okay, so I got all of them updated. Now I say draw now and end. Do I need a pause? I don't think so. It is going to be slow by itself. Okay, now let's see if I need to fix the axis as well. Yes. Okay, now one thing that you have in many animations is if the X min, X max, Y min, and Y max change considerably, then it's like holding your camera at it, it moves to the left and right. And that might not be so convenient to watch. So my advice is make your X min, X max, Y min, Y max big. So zoom out and then keep it fixed. So here you see, for example, your Y values and X values can never be more than sum of L1 plus L2. So X between negative 1.1 and positive 1.1, Y the same. So before I do anything here, at the end of it, I say axis from negative 1.1 to 1.1, or let's make it 1.5 for simplicity. And then from negative 1.5 to, again, 1.5. So I limit my axis to a fixed region so it doesn't update itself. Yes? Correct? So you can easily see that if I want, I can make it more. And then if I want, again, every time I take that, I can do a what? I can keep taking a snapshot, right? And then finally converting it into a movie. So here, first time I do it, I take my first frame, first snapshot, and that's my first frame. And then every time after that I take it, I add 1 to the frame number, and I take one new shot and add it to my movie. So here, when I say that, there we go. I add 1 to my frame counter, and I add that new snapshot to my variable movie. And finally, I can what? If I want, I can convert it into a video, right? So I say V is double pendulum. AVI, open it, write this video to it, and then what? Close it. So now look. Here we go. Right? Now it should be written to the video. Let me check. Here, it's working on it. Oh, now it's here. Double pendulum. Look. Here we go. So now you can import it into your PowerPoint presentation. Okay? You can trace the endpoint or do anything you want.